Troutwine with Offshore Engineer TV, and we're here today again with Philip Lewis, the Director of Research for World Energy Reports, to discuss again some of the traction and movement in the growing offshore wind market. Phil, as always, a pleasure to see you.
Yeah, pleasure too, Greg. Thanks for having me back.
Absolutely. So, Phil, I know you have a true global view of this offshore wind sector. As you know, floating offshore wind is still in the development phase. Why exactly is there so much excitement then about the floating offshore wind sector?
Okay, Greg, as we discussed in our previous chats, bottom fixed offshore wind farms have been in operation since 1991. And so this is not a new industry. We saw true industrialization of the sector over the last decade and the adoption by more and more European and East Asian countries of this increasingly cost competitive technology. But the reason that we at World Energy Reports are so interested in floating offshore wind is based on the amount of resource available over 60 meters of water depth. That's the general threshold considered for floating solutions. Some 80% of the world's wind resource is found in deeper waters suited to floating wind foundations, 80%. These resources are generally able to access higher quality wind resource. Further, the floating structures can deploy larger turbines which support high capacity factors, which means they produce more electricity.
You know, there's a growing cacophony of information on the offshore wind in general and on floating wind specifically. Can you give us insights from where you sit? Where exactly are we today in the development of to bring floating wind to utility scale?
Oh, good question, Greg. We're passing from the prototype and demonstration project phase towards industrial scale floating wind farms. World Energy Reports, we forecast that floating wind installed capacity will reach between 8 to 10 gigawatts by the end of this decade. And next decade, we expect to see more than 60 gigawatts of floating wind farms commissioned. This represents a significant opportunity to those in the supply chain. The World Energy Reports, we see opportunities for traditional offshore and marine companies that support the oil and gas sector, like offshore yards, mooring system chain and anchor manufacturing, and OSV operators. We also see exciting opportunities for those not traditionally involved in the offshore oil and gas market, such as precast concrete and in situ concrete contractors and manufacturers of synthetic rope. World Energy Reports, we are tracking some 60 floating wind substructure concepts. 38 of these concepts have been tank tested and 20 scale tested in the field, and 3 concepts have been demonstrated at full scale. Only 2 concepts have reached the stage of pilot array to date. Pilot array meaning multiple turbines at full scale, although several more concepts will reach this stage over the next couple of years. We expect to see the first pre-commercial arrays, that's under 100 megawatts or up to 100 megawatts, by 2022, and the first commercial arrays over 100 megawatts by the middle of the decade. At World Energy Reports, we expect the pace of development to be quick, and this provides good opportunity for the supply chain. But we do not feel that the supply chain has fully embraced the scope and scale of the opportunities that exist in this sector.
Okay, Phil, as you well know, there are a lot of opportunities, there are a lot of challenges.
Mhm.
When you look at the floating wind and the promise of floating wind, what are the primary hurdles that you see to delivering on the promise that floating wind offers?
Good point there. Um, Firstly, I think most people would struggle to picture how big these units can be. If we take an industrial scale floating wind farm, you could easily expect to see 50 to 100 steel or concrete substructures to meet a 200 to 300 day installation weather window. Taking the example of a steel floater, that could be 150,000 to 350,000 tons of steel to be produced in 2 to 3 years, with each 2.5 to 3,500 ton structure requiring some 6,000 square meters plus of laydown area and assembly area. The structures are physically large and will be required in large quantities. In addition to waterside laydown areas, we need assembly berths and wet storage, with the turbines having diameters that exceed 200 meters. We see a major opportunity and constraint in the quantity and capacity of anchor handlers and construction vessels to tow wind turbines, pre-lay moorings, and hookup systems. There's also a specific challenge to adapt offshore oil and gas mooring solutions to floating wind, addressing weight, quantity, and footprint of the anchor mooring lines. And dynamic cable array and high voltage export cable manufacturing and installation capacity is another challenge to address, especially the manufacture above 66 kilovolt dynamic export cables, which really is very much in its infancy. And finally, there is the inspection of large numbers of in-water components, and where the question of whether you do it in situ, floating to floating, versus tow to port repair and maintenance programs is yet to be fully addressed.
Phil, as always, your insights are concise and greatly appreciated. Thanks so much.
No, thanks, Greg.